Welcome back. Now in this tutorial, I'm going to implement the delete first operation. That's going to delete the first node of the linked list. Now, if you delete the first node of the linked list, obviously the second node is going to become the first node. That means the head pointer after this operation will point to the second node. Now there is a special condition that we need to consider. If the linked list is containing only one node, in that case, we are going to delete that, right? In that case, obviously the head and tail both has to be assigned with null. And we need to do that here in the delete first operation. We need to take care of that situation. But first of all, what we need to do is to check whether the linked list is empty or not. So I'll do that by just checking the node count there. If the list ptr arrow node count, and that is equals with 0, that means the linked list is empty. And we should return an abstract value. Let me just change something there. You see that void there? The return type of this function should be integer because we must return the integer content of the node that is kept within the node, right? On deleting the node, the content of the node, the integer value must be returned to the caller because the caller may need that value for its own purpose. So I'll be changing the return type of each of these delete operations. The delete last has been changed as well. I'll be implementing this delete last in the next tutorial. Okay, let me change the prototype declarations there for each of these. Okay, so I'm changing the prototype declaration of each of the delete operations. The return type is changed from void to integer there. Okay, so now let us implement this. So if the node count is 0, we will return some absurd value to the caller, -9999. So if the caller gets -9999, it understands that the delete first operation could not delete a node because the linked list is empty. Now we are going to check if there is only one node in the linked list or not. List ptr arrow node count, and if that equals with 1, then there is only one node. Otherwise, there are many nodes in the linked list. So let me write this comment there. And in the else part, there are many nodes, and we need to delete the first. Okay, now I'll take a node pointer there in order to point the first node, in order to have the address of the first node, or let me just give the name first. And we can pick up the address of the first node from the head. Okay, this ptr arrow head will give us the address of the first node. So now if there is only one node, then we need to assign null to both head and tail pointer. Okay, so list ptr arrow head, this should be null, as well as lstptr arrow tail, this should be null as well. And we need to make the node count 0. I'll do that later on after the else part. Now otherwise, if there are many nodes, then obviously the head is going to point to the second node. That means the next pointer field of the first node has to be assigned to the head pointer. Okay, let's do that. List ptr arrow head, this should be first arrow next. Now the first arrow next contains the address of the second node, right? And that we are assigning to the head. So after this statement at line 186, the head pointer is going to point the second node. So we are done manipulating the pointers there. Now what you need to do is to deallocate the first node from the memory. Now we use the free function in order to deallocate the allocated space by malloc or calloc that we had allocated dynamically using all this dynamic allocation technique. So free function actually will deallocate this dynamic space and will return that to the free store. So that's done. Now we just need to decrement that lstptr arrow node count minus minus. We are decrementing the node count by 1. One more thing that we need to do, we need to keep the data that is there in the first node, right? Okay, so I'm just picking up the data there and placing that in a variable data at line 177. So first arrow data. So we get the data there. And at the end of this, what I'm going to do is to return that data to the caller. And that's it. We are done implementing the delete first. Now we can just add it in the switch case and we can see how that works. So that's the case number, okay, here it is, case number 8. So I'm going to implement that case 8. I already did that, as you can see it here. I'm calling that delete first operation and getting the data from that delete first in a data variable, and then we're checking whether the data is -9999. If that is -9999, the linked list is empty. As you can see that I'm printing that message at line 265, and then in the else part I'm just printing the data that was contained in that first node that we just deleted. Okay, let's go ahead and run this. So I'm in the folder where I have kept this file linklist.c. So let me just compile gcc linklist.c. Okay, it has been compiled successfully. We do not get any error or warning there. So let me just go ahead and run that. We get the menu there. I'm using option 1 to load from file. The linked list will be created. Yes, it has been created successfully. I'm just printing the content of the linked list. Here you see all these are the data that is kept in the nodes there in the linked list. Now I will call the delete first operation, that option 8. And you can see that the first node has been deleted. Data is 100. Yes, indeed, the data is 100 of the first node that was deleted. So now I can just go ahead and display that. And you can see that it starts from 300 this time. Earlier it was 100, and this time it is 300. Earlier the second node contained 300 there. You can see that. Okay. So now I can just delete once more, just calling 8 again. Now you can see that 300 has been deleted. That means the node that contained 300, that was the first node, that's deleted. So I can just print the list again. Yes, it's 150. That's from that is the first node. Okay, I mean 150 is the content of the first node now. So okay, you can see that delete first is working fine, and you can go ahead and check that. I'll recommend you to draw a picture of linked list and put this data inside each of this node, and then try this algorithm, I mean this program. Just go through the steps of this program step by step and then find out how that works. Hopefully that will help you to understand it better. In the next tutorial, obviously we'll be doing the delete last operation. Now in that case, we need to iterate through the linked list to get the address of the second last node that is required for that. So I'll show you why that is required and how we can delete the last node. Thank you very much for watching.